The history of chemical reactions dates back to over 250 years ago, approximately during the 1700s. Wow, that's a long time. Substances were classified as elements and compounds such as gold, hydrogen, oxygen, and carbon. The first elements that were studied were gases. One chemist that was responsible for playing an important role in the development of chemical reactions was a man named Antoine Laurent Lavoisier. Nice drawing, eh? He was a chemist from France and was especially notable because he invented 33 elements, or substances that could not be broken down into simpler forms. After his inventions, other chemists began expanding on his ideas. I guess you could say they looked up to him and his ideas, just like how little kids look up to Superman. Okay, maybe that wasn't the best example. It took Lavoisier some time, but after research and experimentation, he was able to accurately measure the weight of elements, and his research eventually led to other further breakthroughs.
Today on Chem Channel, we will be talking about synthesis reaction, which is one of the chemical reactions. So the definition of synthesis reaction is a combination of two or more substances and a compound result. The formula to create synthesis reaction is A plus B is equal to AB. So, a substance plus a substance is equal to a compound. A general examples are sugar and butter create a synthesis reaction which creates caramel. Number 2 is in comparative to biology. Did you know that sperm cells and an egg cell make zygote, which represents a synthesis reaction? And lastly, the color blue and the color red combine to make color purple. This represents synthesis reaction as well.
Synthesis reactions form a single product from two or more substances, either elements or compounds. Let's try an example. Sulfur dioxide gas is bubbled through water. From this equation, we need to find the two single compound reactants. In this case, it would be sulfur dioxide and water. So we're writing a skeletal equation for this reaction. We would have SO2 as gas plus H2O as liquid forms H2SO3. When writing a word equation, it is important to note that your equation will only consist of the names of the metallic and non-metallic elements, nothing else. So for this reaction, we would have sulfur dioxide gas plus water forms sulfurous acid. Now we have our reaction. If we were to balance this, the first thing to consider would be the law of condensation of mass. Sorry, I meant conservation. The reactant side must always be equal to the product side. There are no atoms added or destroyed, only changed.
Some real-world examples are iron plus oxygen combine to make iron oxide, or you can say the rusting of iron. Number 2, Coke plus ice creates the drink that you love to drink, and it is also a synthesis reaction. And lastly is carbon reacts with oxygen, which produces carbon dioxide.
Synthesis is often used for industrial purposes, such as how ammonia is synthesized from nitrogen and hydrogen and is used to create fertilizer. It can form fibers that are used to create plastics, herbicides, and insecticides as well. Some examples of synthesis reactions include how calcium is combined with oxygen gas to form calcium oxide. Another example is the synthesis of magnesium and nitrogen to form magnesium nitride.
An example of synthesis is the formation of kidney stones. When you don't consume enough calcium, there is a high chance that the calcium you do have will bond with oxalate in your gastrointestinal tract. Calcium oxalate is what makes up the majority of the kidney stones. The chemical equation for this reaction is Ca plus C2O4 forms CaC2O4. It's pretty neat that our own body contains chemical reactions. So the next time you skip that glass of milk, think of the reaction that may occur inside your body. It won't be a very nice one. Another biological chemical reaction which takes place in the human body is the formation of protein molecules. And when you guys think of protein, you think of fruits, veggies, and meats. But I'm talking about a protein molecule. These reactions are the building blocks in your body in terms of body growth and repairing damaged tissues. The building blocks in this case are amino acids. As they undergo a reaction, amino acids join together to form a protein molecule. Now, that's the kind of reaction that you want.
Did you ever take art?
No, I can tell.
What if I randomly get tired?
Oh, why are you laughing?